All right, so how to make a buffer. There are actually two ways to make a buffer. One is you just mix some stuff together that you already have on hand, and the other way is going to involve doing a reaction. So to make the mix, you're going to do a weak acid, and you're going to do its conjugate salt, and you'll add those together. Or you're going to go ahead and do a weak base, and guess what? It's conjugate salt. So what are some examples of these? All right, so if you're thinking of weak acids, like any weak acid, like CH3COOH, its salt is just the version of it without the H. So CH3COO minus, and then it's going to have something positive like an Na or K, or even like an NH4 plus. Something positive is going to be balancing that charge there, and then it's a salt. So it's just the acid without the H. Something else is there besides the H. Then if we look at the weak base, a lot of times we have ammonia. So it'll be something like NH3, and then you're going to add an H to it, so NH4 plus, and it's going to have something again balancing it, Cl, Br, something like that. So that's the salt of that. So you'll just go to the area that you store acids, pour some of that in, go to the area where you store the salts, which are like solids, like the jars of solid, and you're just going to mix the two together and you'll have a buffer. Now that'll be in molarity, and like the acids come in molarity, and then the salts are solids, and so the liquid that you add them to, it's that acid that's already a liquid and it's already dissolved in water. So in this method, you don't have to do some new volume calculations that you'll see in the next method. You're just given the molarity of what the two things will be at equilibrium. So when we mix those two together, notice the left I've got the acid and the right I've got the salt. So you're going to have a Ka, and you're going to have a value there as an initial. Of course, you're going to lose. And you're gaining on the right-hand side, and notice you're going to, this time, you'll have a value that initially starts for that CH3COO minus. So that's your acid. And then here's your salt. So that's what's different about the ice charts. You got the Ka, but now you've got something for both places. And it actually makes the math easier because and also you're going to be throwing out both of those x's beside the number, so it definitely does make the math easier. You'll see as you do some of these problems. So that's one way to do it. And these ice charts, the calculations are in molarity, and notice that they show reactant and product. So the second way is where you react two things together. You're going to react. Notice the other one started with a weak acid and a conjugate salt. This time we're going to do a weak acid and a strong base. That's going to make your salt. That's what it's going to do. Or you can have a strong acid and a weak base. You've got to have a combo, and they're going to do a reaction to make that salt in the earlier equation that we were using. Once it makes a salt, then you have your buffer. And you'll notice over here, there's one of these ICF charts where you have to actually do a reaction, and you're going to be subtracting out numbers, and you're going to have two final values. And what we then focus on is that H, that CH3COOH section, and then the salt section. And again, you're going to have less of the strong thing and more of the weak thing when you're doing these. Then once you have that, those two values, you're just looking at those two, and you're going to do an ice chart with those two values. So then it's like what I was saying earlier with the salt and the acid. And remember, you'll solve for x, and then you'll do your pH of the log of HCO plus. And things will pretty much looking the same at this point as to what you've done before. I do want to point out that that ICF chart is always solved for in moles. But remember, to do your ice chart, you need to have that one in molarity. So moles versus, remember, you're going to have to divide them by the total liters to get to molarity. So what if we had, that? Let's say the pink is the acid, 10 milliliters of the pink thing, and then we had 5 milliliters of the blue thing. Let's say that's your base. Well, when you mix them together, you're going to have a new volume. See, your new volume is now going to be 15. So your moles have like more liquid to swim around in, kind of. Let's say we initially had 1 molarity, and we're going to go ahead and figure out how many moles that is. So I'm going to take the, that's how many milliliters turned into liters, the 0.01 liters, times your 1 mole equals molarity. And it's going to be 0.01 moles. That's what I'm going to say, moles of acid. Now, my moles of acid now are going to be divided by, once they're combined with something else, it's got a higher volume, and it's going to be divided by the 15 milliliters. So I'm going to plug that in, 0.01 divided by 0.015, and that's 0.6666. So you can see this is not the same molarity as the 1 molarity. They're not the same, they're different. So when we do our ice chart, we have to pay attention to the fact that when we're doing a reaction, we're mixing liquids and we're changing volumes. Now, there is a shortcut around this that you'll find out, but it only is true for buffers. But there is going to be a shortcut around it. So like I was saying, you need moles in that ICF chart, and then you need, for the ice chart, you need things to be in molarity once you finish that.